Good morning. My name is Jose Rodriguez, and this this presentation is about detecting malicious code with machine learning. In introduction, malicious programs day to day can be detected by antiviruses. The problem with antiviruses is that new viruses or silly viruses can go undiscovered by them. The point of using machine language is to discover them so it can be detected right away from any suspicious activity. The problem of this is that I have is how to detect malicious programs with machine learning. Malicious programs, as a definition, are programs that could cause irreparable damage to computers by either corrupting data, recording your information, or stealing them, locking your computer and files from ever using it. Again, unless you pay them a ransom, which is called ransomware, and the malware can be detected from different forms. One of them is static analysis, which means reading the source code of the malware and trying to see the behavior of properties of the file. You can be monitor it by inspecting the file format, which is viewing the file metadata to see if any imported and exported functions is called the string instruction. So you can see the output of a program is outputs after running them. Fingerprinting if there's any cryptographic hash computation, and, and like stuff like hard-coded usernames, file names, and registry strings. Antivirus scanning if the file is a well-known virus, then it can be detected as easily as that. And disassembly, which means reversing the machine code to assembly and informing the software logic and intentions. The other way is by dynamic analysis, which is monitoring the behavior inside a virtual environment instead of analyzing the static information. The virtual environment can be a sandbox. The first article I'm gonna talk about is called a static malware detection system using data mining methods. This study focuses on detecting if a malicious Windows portable executable program is malicious or not using static analysis. The dataset that this study has is 2,000 malicious programs and 10,000 clean programs in portable executable file format. The malicious programs were obtained from BX7 virus collection database, and the clean programs were obtained from download.com. The, the study extracted the features from a portable executable using a custom program called PE-miner to extract all PE portable executable header information. It could also extract the API calls that can be used to detect any malicious behavior, for example, if there's any file creation, memory deletion, etc., and the dynamic library names. Here we have the table of the extracted features. As we can see, there's the unique DLL features and the all the information of the portable executable headers. In this study, the features are selected by how frequent they are in the malicious programs. And here we can see that kernel 32.dll is very frequent because that's a program that malicious programs use to take control of the computer mainly. Another that we see uses user32.dll and size of initial data, which it can be used to create files. Classifiers that are used in this program are support vector machine J48 and naive bytes with a class variation of 10 folds. What's important here is the PE heading with a classifier J48, which has a 99.5% of direct rate and a 2.7% of a false positive rate, which means it's the most accurate and successful of all the other classifiers with the PE header feature. And the most inaccurate feature is DAL with the classifier naive bytes. Here's a graphic of the whole program. The program takes an PE file, which is then mined with a PE miner to take out the PE head and the DL and DL call function, which is then put into feature database to then put into the feature selection to check how frequent is each PE header or DL call function, which is then sent into testing set and training set so it can be put into the learning algorithms to create the classification result. The results of this study were that the J48 is the most accurate classifier, and the only needed feature that can detect zero-day biases is the P protocol executable header feature, with the best accuracy is a 99.5% and a false positivity rate of a 2.7%. The next paper is a thesis called Machine Learning Methods for Malware Detection and Classification. This thesis is based on a more dynamic approach using a sandbox to test the malicious programs. The dataset used for the study has 1,156 malware files and 984 benign files, which are clean files. The manner that the features were stat were that the study chose API calls in any API calls in which were successful API calls, failed API calls, and return codes, which were generated by the programs in the virtual sandbox that the study was using. The study selected the features with a random forest classifier and the I language package Boruta. The Boruta language is mainly shuffles the feature and weights the features so that the less important features can be deleted from the most important one. The classifiers in this study uses naive bytes, J48, random forest, K nearest neighbors, and support vector machines. They are tested with two class classifications and multi-class classifications. And this here is the results of the classifier, in which the most interesting one is that naive base has 70 is the lowest one, which at 72.34% in the multi-class accuracy, and in the binary 55%. The random forest is the one with the highest with a 95.79%, with a 96.8% in binary, and but it has some false negatives. The As a result, the random forest is the most accurate in multi-class and binary classes, but it is recommended in binary classes to use support vector machines because it has no false negatives. In conclusion, from these two studies, I deduce that making my final project based on detecting malicious code from static analysis will be easier than dynamic analysis, and how to create a dataset using the programs malicious codes Also, I got the opportunity to learn more about how malicious program can be detected. Here are the references. And thank you very much. Any question you can ask me.